Electrostatics will start today. In that, of course, will in the beginning itself decide the agenda for the few days to come. Okay. Look. This comes under a basic unit, big unit. I'll give the unit headings.
Yes.
The main thing I can put a big heading like electromagnetism. See, for 12th class, we have electromagnetism, optics, waves, modern physics, and semiconductor physics, like that. So, in this electromagnetism, once again, 1, electrostatics, 2, current electricity, then force on a current due to magnetic fields, for magnetic fields formed by currents, five, electromagnetic induction, right? 6, AC circuits, alternating current circuits. Of course, 2 more chapters I need to add here. Magnetic properties of materials, eight, electromagnetic waves. Remember, this unit takes some 40, not 40, 50, not 50, even more than 50% of the 12th class syllabus. It's a huge unit, like mechanics in first year. Okay?
Yes, sir.
Right. Hope you finished. I'll continue to talk.
Done, sir.
Right. Now, what do we do under electrostatics once again? Look. First, actually, I'll give an introduction for the whole unit, actually. After that, I'll go for electrostatics lesson, basically. So, remove this one. For the unit called electromagnetism, I'll give introduction first. That is very important. Later, we'll come to this. 1. Electric charge, force, and field. Okay, Gauss's law, electric potential. So as we keep looking at these topics, you must be already thinking similar things we have done in gravitation. Yes. So electric potential and electric capacity. Actually, it's a habit for people to put an electric capacity under electrostatics. With there is a reasoning for it, of course. But generally, what I do is I'll do these three first, then finish this current electricity, come back to electric capacity. Okay, because currents are involved in discussing a capacity, a capacitor. Because before the steady state is reached, that is, before you say it is electrostatics, some current electricity is involved in that. Some cell is there, current flows. After some time, the charges will come into equilibrium on the plates of a capacitor. So all the process which happens before this electrostatic conditions come, they're very important, actually speaking. So remember, this is how I'm going to do the things. All right. Now,
Yes, sir.
the basic introduction. This sets the tone for the whole unit. Okay. This is about force and fields. Okay. The statements we make below. Statements we make below are true in an inertial frame of reference. Frame of reference fixed to lab. What do you mean by this? What it means is, you can almost for all practical purposes can think that you are in your college physics lab, standing there on the floor and looking at things on the table. That is, you have for example, a metal sphere which is rubbed against by some cloth, for example. So that metal sphere is standing on the table over an insulating stand that will have charges formed on it. The charges are at rest as you watch from the ground. You are not going to think yourself to be traveling and then watching the charges. Because, of course, traveling with uniform velocity may not matter. Even that will keep it aside for a while. We'll think all the time that we are at rest in a lab frame and discuss things. And of course, when the charges accelerate, things change even in a different way. So the whole lesson of electrostatics will be, of course, not only electrostatics, but even the whole lesson. When we say electric field, when we say magnetic field, we actually are meaning to say that we are giving these names, those fields standing on the ground. Okay. So I'll make few statements here. Hope people are listening.
Yes, sir.
1. Electric fields are produced by all kinds of charges. Electric fields are produced by both stationary and moving charges. You do not have to bother now what is stationary and what is moving, because you already told we are standing in the lab. So you're not in any reference frame which is moving. So stationary means what? Some charges are stationary on the table. Or moving is what? Some charges are moving in a wire when you connect it to a battery which is placed on the table. So electric fields are produced by both stationary and moving charges. All right. Now, electric fields exert force on both stationary and moving charges. Hope you're getting something out of it. Electric fields are produced by both stationary and moving charges. Electric field exert force on both stationary and moving charges. Here, we're talking about how fields are produced. And then we are saying how the fields exert force on charges. Okay. Can I continue, children?
Yes.
Yes, sir.
Right. The third statement will be magnetic fields are produced only by moving charges. Magnetic fields are produced only by moving charges. And magnetic fields exert force on moving charges only. Magnetic fields exert force on moving charges only. So, like I told you, this decides the agenda for the whole electromagnetism. People keep struggling to understand things later, or keep arguing over things later, if they did not start with this kind of a what you call rules in the beginning itself. Of course, I'm saying rules, they're not rules, they are basic ideas. So before I continued, do you have anything to say, Aryan? You can take them as rules, axioms, and continue, but you might also think a little more than that. You can, okay, I'll give some examples so that you start thinking about this.
Okay.
Right. You need to keep talking and get things cleared. Say, I have an electron at rest here, another electron at rest here, at some distance from each other. Both the electrons are at rest. Where? At rest. At rest. But who is saying at rest? Because, you know, I've been telling you all the time, this rest and motion are not absolute. They have a meaning only in a particular reference frame. So I could put one reference frame like this, that is a coordinate system fixed to a lab, for example, and you think yourself to be standing at the origin of this coordinate system. Now you say the electrons are at rest. You're not going on a car, for example, with some acceleration like this, okay, while watching the electron. You are simply standing in the lab, and probably somehow you created 2 electrons on the table, okay.
Yes.
My question is, what fields do they form? And what kind of forces they experience? What kind of forces do they experience? So if you have seen that those 4 statements, try to apply them for a while. Come on, Aryan.
They form electric fields.
Yes, both of them form. This is a question, right? Now the answer, this side, if you write, what will you say? Both of them form, tell me, electric field. And each of them experiences electric force. Experience electric force. In fact, force is given by the Coulomb's law, which we'll be discussing under electrostatics. This force and field are given by Coulomb's law. And since you've already seen gravitation, it's not so difficult to talk about fields now, right? The field idea is there because we would like to explain action at a distance, action through space. Electron are not in physical contact like this, but still they experience force. So we say that there's a field of, there's electric field around this electron. That field exerts force on this electron. And there's another electric field around this electron. That field exerts force on this electron. Okay. Hello.
Yes, sir.
Yes.
Yes.
So can I continue? Vaishnavi
Yes.
M, Vaishnavi
Yes,
P, Vaishnavi D is not seen nowadays. So I hope you followed this. You can just give your answers based on those rules. Okay.
Yes.
Yes, sir.
Now, can I continue for the next page?
Yes, sir. Yes.
I am. Now, the second example. Look, somebody is once again watching from the lab. I hope you understood why I'm specifically mentioning this lab's frame and all that. You just cannot say that a particular field is electric field or magnetic field without reference to the reference frame in which you are watching it. If you keep changing the reference frames, what looks like electric field might look like a magnetic field. Okay. Okay, now here there is one electron which is in motion, velocity I'll put. This electron is at rest. So what is going to happen? Anybody can just once again, what kind of questions are asked? This only. What fields do they form and what kind of forces they experience? This question gets repeated. Hello.
Yes.
Yes, sir.
So tell me.
Sir, the first electron in motion will produce electric and magnetic field.
Yeah. The first electron, this one.
Yes.
This is 2. The first electron experiences, tell me, sorry, produces
electric and magnetic fields.
Yeah, electric
experiences only
electric and
magnetic field.
magnetic field. In fact, You can say it has got electromagnetic field around it. Do you understand? The word
Yes.
can be, it is electromagnetic field around it. Second electron.
Only electric field.
Second electron
Produces only electric field.
Produces only electric field.
Electric.
Right. Now, the first and second electron both experience electric force only. Isn't it?
Sir, but won't the second electron experience magnetic force also?
Yes, because this has no velocity.
Yes.
Okay. So both the electrons experience, tell me, electric force only. Of course, due to the electric field of each other.
Yes.
One another rather. So, looks all right, children. Others? Trishul. Just put that he's asked this fellow, new fellow. He's asking, can you send the link? Just put the my ID and password in the group. Somebody. Ishak, if you're not coming regularly, you'll miss so much. I started the lesson long ago and now you're joining. Huh? Ishak, I'm not seeing you every day.
Good afternoon, sir.
Good afternoon. But where have you been all these days?
Sir, I did got the link, sir. My phone was formatted.
No, there's no link actually. We're giving direct password and this one. Now look at third one. Can I go to the next page?
Sir, second electron, it will have magnetic force also.
No, second electron has no magnetic field.
It will experience magnetic force.
No, because this has no velocity. Look, go for this statement. Which statement? Magnetic fields exert force on moving charges only. Okay. So there is a magnetic field around it, but it cannot exert force on electron at rest.
Yes.
Specifically, we'll say if you want. Second electron is not moving. Okay. So the magnetic field of first electron does not apply force on it. Okay.
Yes, sir.
Others, please. You need to keep talking. Then only things become clear.
Yes.
So I'll go to the next question, next slide. Can I?
Yes, sir.
Yes.
Right. Third example. Now I'm watching two electrons which are moving. One is going that way, the other is also going that way, to make it simple. Now, same question you answer. Anybody, others?
They will experience.
Pavani?
Sir, they will produce electric and magnetic fields.
So both the electrons produce tell me,
Electric and magnetic fields.
Yes, electric and magnetic fields.
And
Right?
they will also experience electric and magnetic fields.
Yes. So they will also experience both what? Electric and
magnetic forces.
yes. In fact, the electric force between them is repulsive because both are electron. You'll immediately agree, isn't it? Huh?
Yes.
Yes.
And magnetic force will be attractive between them. We'll see that in future. So, in fact, of course, the electric force will be repulsive, first of all. Anybody has a problem with this? In fact, magnetic force is attractive. Actually, you simply accepted that two electrons repel. Huh? Hello?
Yes. Sir, here won't the magnetic force depend on their velocities?
It depends on the velocities, but it also depends on the velocity directions. Huh?
Yes, sir. Like if they're both the same
If they were
magnitude,
going in opposite direction, for example, they would repel. Right? So here the electrons are having the same direction of motion. We'll show later that if currents are like this in the same direction, the magnetic force will be attractive. And of course, this magnetic force which you're talking now between two electrons is very, 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 very small as compared to the electric force. Okay? Hello?
yes, sir.
My point is, you should not be surprised and worried. How can they attract? Because even the repulsion, you took it for granted, no? We made a statement, like charges repel. But we never mentioned that like charges at rest or anything like that, isn't it? But now we are adding more. If the charges
Yes,
are moving, they'll also experience one more force called magnetic force, but the magnetic force will be attractive or repulsive depending upon the velocities. Okay? All right.
Yes, sir.
Right.
Yes, sir.
So I'll continue for the next question. Next situation. Can I?
Yes.
Yes.
Right. Fourth. I have a current carrying wire. Current carrying wire means metal wire, basically. Once again, I'm telling you, these statements are true in the laboratory frame of reference. Okay. Now, I have a current carrying wire. How does a current flow in a wire? Probably you connect it to a battery. Which I'm not showing here for the present. So there's a current flowing like this. But remember, it is what? A metal wire. In which current is allegedly flowing that way. And I have an electron here at rest. So what will you say about this situation? What will you say about this situation? Come on, Aryan, Trishul, Vamshi.
Sir, current meaning electrons are moving in the wire.
Electrons are moving in a wire, metal wire. Sure.
Yes. So
Only electrons will be moving, not the corresponding positive charges in the nucleus. A
yes,
metal wire is a crystal, is a solid. So the atoms are though they can vibrate around their fixed positions, they don't move from one place to another place. Atoms, the free electrons, the outermost valence electrons are the one which actually are going to form current in a metal wire, right?
Yes, sir.
Now tell me.
So the wire produces electric and magnetic fields,
Right.
whereas the electron will produce only an electric field.
So anybody has any opinion on this? So what Sriya says is wire has what? Both electric and magnetic fields. No, wire has only magnetic field around it. Actually, I was giving you the clues by talking about wire. There are protons in the nucleus, equal number of protons in the nucleus. All that I was mentioning only to give you a clue. There is no excess charge here in the wire. The electrons, though they are moving, if some 1 million electrons are there in the wire, 1 million positive charges are there inside it. So the net charge of the wire is 0, no excess charge. So now you should practically think on a metal or any, say if I have this metal here, if I rub, I'll be removing electrons and get positive charges here. That's how electric field is there around it. But in a neutral metal like this, if you have no electric field at all around this, or electric field of the positive and negative charges will cancel out. Even if electrons are flowing in it also, still no issue, because the metal is still neutral, no excess charge on it. Do you follow the statement?
Yes, sir.
So wire has only magnetic field around it, and electron has, tell me.
Only electric field.
Only electric field around it.
Sir, so the electron will not experience any force.
And even wire doesn't experience any force, right? Because this is electric field, this is magnetic field.
Yes.
So no force of interaction. All right. Hello. Tell me, are you surprised at the result here?
Sir, so if a moving electron does not have electric field, it won't experience electric force.
Moving electron does not have electric field. No. What is that statement?
Sir, because previous cases, we had an electron which had both electric field and magnetic field. But
here the wire has equal number of electrons and protons inside. So the electric field of proton and electron have got cancelled. So around the wire there is no electric field.
Yes, sir. So, but I'm saying electric force also, because field is not there, it won't experience force.
Yes.
Yes.
I did not get you. What is that you're saying? The electron does not experience force here because there's no electric field around it.
Yes, sir, that's
okay, right. And this wire as a whole doesn't experience a force because there's no magnetic field around it. Sorry, magnetic field around this.
Yes, sir. It only has its own field, so no.
So now tell me. Let's try to catch the logic at least. I mean, minimum. I told you you can take them as rules there because they're correct rules. You need not have to bother, and everything will be slowly converted to formulas and mathematics. It's not just ordinary words we need to speak here. Okay, Aryan.
I followed.
Right. Now, can you go to the next one?
Yes, sir.
But only two are speaking. What about Trishul? Trishul, are you there in the meeting? Okay, I'll go to fifth one. So what is the next logical thing in terms of examples?
Two wires.
Wires, naturally, isn't it?
Yes.
No, one wire and electron moving. Now tell me.
Sir,
Pavani. Yes.
electron experiences. Sorry, electron
First talk about the
produces.
fields, Pavani. Huh?
Yes, sir. Electron produces magnetic and electric field.
Okay, I'll write that. Electron has both electric and magnetic fields around them.
Wire has
Fields around it. Right? Wire has?
magnetic field.
Yes, only magnetic field.
And they experience only magnetic force.
Yes, they experience only magnetic force. Correct. That's correct. Yes. Someone has any objection here for these statements?
No.
Remember, every example is a possible application later. The statements you're making that these two things have got fields, so we'll have formulas for the fields. And the experience force, we've got formulas for the forces. And once forces act, what are the initial conditions? Is electron fixed to something? Electron is moving somewhere, and how is it moving later after some time? All that will be the physics part of it. Okay, so you need to recollect all the examples 1, 2, 3, 4, 5 like that after everything is over. Now, sixth example. Now, like Sriya was telling, the case would be what? Two wires. Probably in the same direction. I'm putting the direction of current. They can be in the opposite direction also. In same direction, you will know later that they attract. In the opposite direction, they repel. We'll see that in future. But right now, just about forces and fields, if you talk, tell me. Both the wires have magnetic fields around them. And they experience
Only magnetic
fields.
okay.
Yes.
Yes, sir.
Right. Now I'll give another example. I told you already, this particular introduction which I'm giving today is setting the agenda for the full unit I told you. So at once everything will be very, very clear as to what you're when you're doing those things in various lessons. Now, think of, for example, let me say a harsher magnet. Maybe this is north, this is south. Okay, I place an electron at rest. Could you describe the situation now? The permanent magnet this is. Okay. So in a magnetic field produced by a permanent magnet, I place one electron at rest. Now tell me something. This permanent magnet has a magnetic field formed, which is generally given from north to south, and we call it B. This electron has got electric field only around it. Right? Do you follow?
Yes.
So no interaction. All right.
Yes, sir.
I'll give few more examples because I told you already. Each of them should cover one lesson later. Vedanti Rao, you're coming and going out. And don't blame it on the internet because you've been attending classes for so long. Just arrange a better network, sit in a better place, unless you are in a village, a remote village. So shall I continue?
Yes,
I'm going ahead. Now, let me add one more slide. That screen. Just a minute. I'll add extra slide here. Current slide, insert. No. File. Cannot add here. I should be able to add, right? Extra slide. Sriya.
yes, sir.
Just see from beginning slide show design. Should I go?
Sir, insert.
Insert a slide. That will happen.
Yes, sir.
Okay. New slide.
At the extreme left, it is there, sir.
Only, right?
Yes, sir. Or Control M also you can click it.
I just don't use that type. This thing is on the other side of it. Okay. Now, right here we are. Okay. Now, next one. Eighth. Let me say, yeah, the same situation I'll consider once again. You have the permanent magnet here. Now I make one electron move in that. So what will happen?
So there will be magnetic force.
Magnetic force on the electron, right? Because electron has a magnetic field. This is producing a magnetic field. So electron experiences what? Magnetic. Of course, you might ask whether the magnet experiences magnetic force. It experiences. Maybe you don't see that because the individual electrons inside experience force, and that we don't see the whole thing moving away like that. That I'll come back later. Like what makes a bar magnet form a magnetic field? Even there, the electrons only try to understand.
Yes.
Even this one should experience a magnetic force, but this being big and displaced on a table, it may not move. Right? All right. You can say even the magnet experiences force, you can say, right?
Yes, sir.
Okay, now I'll put known popular examples here. I have a bar magnet, north and south here. I'm trying to bring another bar magnet like this. What about the fields and what about the interaction? Both of them have magnetic field. And they experience what? Magnetic force. You may be thinking, sir, how is this magnetic field formed? Yeah, it is formed because of, once again, those circulating electrons only inside. Do you follow? This is where I talk about all these things in magnetic properties of materials. Don't ever think that there are two kinds of magnetic fields. One is by bar magnets and the other is by moving charges. It is ultimately, microscopically speaking, it's all moving charges only which form the magnetic field. Whether you are thinking of a single charger particle moving, which is very reasonable, practically feasible, or whether there are charges moving in a wire, or whether there are circulating electrons in the atoms, which together contribute to the magnetic properties of a body in bulk. Ultimately, the reason is only moving charges. One more example I can give and finish the whole discussion of these fields and forces.
Sir, here the velocities will be opposite in direction.
Velocities of whom?
Of the electrons inside the magnet.
That we don't know it. Just remember, the electrons are there and they together form the circulating electron, especially this iron. If you take soft iron, if you take, there will be empty unpaired electrons in the d orbitals there. So they contribute to the magnetic field. We need to discuss that separately, actually, how a ferromagnetic material gets more magnetic field than some other magnet. Okay.
So here it will be repulsive. So overall, can't we determine then?
No. No, you need to discuss more details of that. Okay.
Yes.
We are talking in bulk here, not microscopically right now, but at the same time, we are very sure that the microscopic reason is the reason for the outward magnetism for this. Do you follow?
Yes, sir.
I'll finish the whole thing with one more example, because that makes it complete package. Let me say I've got a bar magnet and I'm bringing one, say, a soft iron piece here. Okay, what is this I told you? Now, what's going to happen? You tell me. Just this soft iron has no magnetic field around it, just like that. You understand? It has to be magnetized to become a magnet. Even this bar magnet was magnetized first. This is a magnetic material, all right, but it has no magnetic field on its own. But the moment you bring it here, it creates a magnetic field here, and it gets attracted. Do you understand my point?
Yes.
This field of this bar magnet induces what? Magnetic field
in the soft
iron, and they attract. It's slightly different from these two. These two already have magnetic fields, but here this is no magnetic field to begin with in the absence of this bar magnet. But when you bring this iron piece near this bar magnet, this induces magnetism here, and there will be attraction. Do you follow?
Yes, sir.
Yes, sir.
I can give a little more other examples, but probably for that we need to know a little more of the meaning of diamagnetism and paramagnetism. Right now, I'm not going to do that. That should wait. We'll do that in magnetic properties of materials. But finally, like I told you already, all these things will be converted to mathematics. And for each of them, there are empirical laws given by scientists. laws derived from the experience and few arguments. Okay, so just can you recollect all the ideas here, or at least today's lessons main ideas? Come on, Aryan. Our lesson is actually, the subunit is actually electrostatics. The main unit is electromagnetism. The subunit is electrostatics. In that, various lessons we have. But even before we go for electrostatics, I've provided you with an introduction, which is the introduction for the whole electromagnetism. Complete electromagnetism's introduction is given. You can watch the video once again. I'll upload it today, but I want you to be very, very clear about these ideas. But do you have any very basic question to be asked here? I'll ask you. I'll see. You just took the rules for granted and explained it. It's not a bad idea. After all this, I'll ask you a question. What is electric field? What is magnetic field? Or you might say, why only moving charges form magnetic field? Tell me. Hello. It's not a big question. Try to understand. People get unnecessarily confused with this. Look, our experience, day-to-day experience, is the beginning of inquiry, and scientists started developing models. Our basic experience is about force, isn't it? When I take a bar magnet, when I put one bar magnet table and bring another, try to push this bar magnet towards it, that bar magnet, if it is free, it will start moving backwards, and you only from a distance you can push it that way. But if that is fixed, as you keep bringing it towards it, your hand feels that push back again. Are you following my point?
Yes, sir.
So force is one which we know from experience. Okay, but people found, especially for the forces which act through space without touch. Without touch, somehow we got an idea that touch is producing a force. All right, that's not bad. But especially those forces which are acting through space, people gave a model called field. Field spreads in space, and that field applies force on that. But now people found many forces. People found something called gravitational force. People found, once again, even for charges, not one force. There are two kinds of forces. One force is there because of the position. One force is there because of velocity. Right? So just position depending field is electric field. Velocity depending field is magnetic field. And velocity dependent force is magnetic force. Position dependent force is electric force. These two forces will be different, children, believe me. If I've got one electron here, another electron here, another electron here, the repulsive force is along the line joining, and it will go away like that. But so, for example, if there is one wire like this, and if an electron is going like that, this force is perpendicular to the velocity, whichever way. We'll show it later. So this force is all the time perpendicular to velocity. So two different kinds of forces people observed, and therefore they said there are two kinds of fields. That's all and nothing else. Okay. Gravitational force is one separate. That's because of mass people found out. But even for charges, people found two different kinds of forces, which of course we'll keep elaborating that as we keep doing the lessons. But this is as simple as that. To account for two different kinds of forces, two fields are introduced. So velocity, if a velocity depending field is magnetic field. Velocity depending force is magnetic force. Position depending field is electric field. Position depending force is electric force. Position is R basically. Velocity is V bar. So we'll show that in future as we keep doing that there are two kinds of forces, therefore two kinds of fields. Okay.
Sir, so they're dependent on the motion of the charge from an inertial frame.
Yes.
That
Therefore,
is
if we keep
ideal.
changing forces will be real, try to understand. But if we change the reference frames, you might say that previously the force which was due to electric field may be due to the magnetic field, you will say now. No
Yes.
problem at all. And people gave already that transformation equations from one field to the other field or from one force to the other force. In fact, people think there is only a single force called electromagnetic force. There's a single force called electromagnetic force. One component of that is electric field. The other component of that is because of magnetic field. So there's an equation for that, one basic equation for that, which will be slowly coming into discuss. Huh?
Yes, sir.
All right. So with that introduction, I'm closing it. And for these lessons, actually, Rajnik and Halliday is the best book. You can read your textbook, your intermediate textbook or H.C. Verma, but proper ideas will be there in Rajnik and Halliday. So, in fact, actually, when I speak, you people all the time have issues because you don't come prepared. The best way to learn is to read a textbook, good textbook. Whether you understood it or not, no issue. But at least you should get familiar with the words. Otherwise, later what will happen, you'll only look for familiarity. So, for example, when I'm talking something familiar which you learned previously, you will think you've understood it. And you learn new things today, and tomorrow, once again, these things look familiar, you say you followed it. So the familiarity is not understanding, believe me. The feel, it couldn't have been otherwise. That's called understanding. But anyway, I did not bother you with the understanding in the very beginning. I told you the rules of the game. There are two kinds of things I told you already. Either you understand it properly, get that wow feeling, or you follow the rules or axioms and apply it. Both are agreed. And a combination of both of them will be when exams say all that, it is going to be good. Okay. So with this introduction today, I'll be closing the session for today. Okay.
Yes.
Right.
Thank you.
Thank you.
Thank you.